everything good comes to an end. It's been amazing days here in Cambridge, being part of the unboxing of the Speedset1060 from Agfa. I know that I would call you co-host right now, because we're actually going a walkthrough of the 1060, so you can have a little bit of insight what's actually going on. Matt, you told me yesterday that you were almost emotional because of this, right?
Right, yeah, absolutely. Yeah. And now, as you said, the end of 2 days, it's been a lot of energy, hype, excitement. Yeah. Well, we've concluded those 2 days.
Good people here, right? I mean, both on the analyst side, on the customer side, on the staffing side. I mean, I think it's been wonderful.
Yeah.
Yeah, and we're here for a reason. I mean,
yeah, absolutely. Yeah,
2 years, 3 years of work, and here the beast is, right?
Here we are. Yeah, this is it. SpeedSet. I think again, that emotion side, that energy, but just seeing the looks on people's faces when we revealed it, not just to the customers, the prospects, but the press, the analysts, the investors, really excited for the trajectory that Agfa's on with what they've seen.
When you get time to listen to some of the interviews I did, I asked them if this machine kind of ticks all the boxes for the need. Analysts, it's so convenient. They can tell you what you have to do, because they don't have to do it themselves, right?
Yeah,
you just make it, right? And you did.
Just make it happen.
Just make it happen, right? Let's go and see what the machine is here. So we're not talking so much about the things before and after, because it's not running, but you have a Mabec collaboration, just to say, on the feeder and on the delivery, right?
Right. Yeah. I think what we really decided very early on was we can't do everything ourselves, and let's partner up with industry experts like Mabec, who have been around for almost as long as Agfa, if not longer, supplying the offset analog world with well-designed industry standard feeding and stacking systems, and they gave us what we wanted. Yeah. Okay.
So it has been a real collaboration.
Yeah, it really has.
Not just buying something off the shelf.
Because what we're trying to feed here is a multiple application range. We've really partnered up to bring that solution to market.
Okay. From the feeder, of course, it goes into the machine, right?
Right. Yeah. So I guess we're top feeding sheets, feeding in at high speed. We're talking about a machine that can do this game-changing killer speeds, up to 11,000 sheets an hour. We need to be able to feed that on demand at high speed, and that's where Mabec have delivered really into the alignment registration part of the press.
And as far as I know, it's crucial that you have precise registration of the paper in an inkjet press, and it's crucial that you make sure that it stays in place while you're printing on it, right?
Absolutely. Well, the registration, the pre-sheet registration, of course, but as I said, we're applying this machine at such a speed. We're putting ink down, we have to dry it, the sheet needs to be perfectly formed when it goes to the stack. What happens afterwards, the die cutting, folding, gluing, we need to keep that registration. So
also, as you said yesterday, making a digital machine, it needs to also fit into the analog world with the gluers and the finishing products that you need anyways. Yeah. But let's go through. So basically here we have from the feeder basically coming in, you have the registration. I can see that thing is measuring the thickness of the paper.
It's a bit also to do with the substrate height. So with the paper-based materials, particularly in the higher end thicknesses, the corrugated, we have this mechanical detection system. So if it does detect a bad sheet, it doesn't do any damage, for one, but also it doesn't find its way to the end stack. It's rejected. So what ends up at the final stack is good quality and printed and saleable printed material.
You mentioned to me when we met yesterday that this metal conveyor here, which has all these holes, is a patent that you have, right?
Yeah, that's right. It's our own patent.
So what does it do?
So it's a steel belt, and basically this is how we're able to run the machine at such speed. We have our own vacuum system.
Okay, so it's a vacuum.
It's a vacuum system, yeah. So it's a belt with the vacuum platens. It gives us high flow, high suction, good levels of friction to pull the sheets down, paper all the way to corrugated.
And then now we have the paper in the machine. And one of the questions people often ask when we talk inkjet, should it be pre-coated? But you have the coater built in basically, right?
Yeah, absolutely. So the whole concept here is in the same way as people think about inkjet and colors. well, let's flip it up a little bit and let's have an inkjet primer, pre-coater. And here, this is the area, the station for the primer.
We're a little bit too fast actually, yeah, because that is just the dryers. This is actually, so that is also because one of the things that is important is that this machine has digital coding and not an analog coding,
yeah,
right?
So what you can see and what people will begin to learn and understand is the print engine is designed the same, whether it's a CMYK with a primer or whatever else we decide to do. So it works in the same way in terms of the print bars coming into play, jetted at high speed on demand. So some materials may not need it, but I'm sure when we look at the applications, the fact that it's inkjet gives us a nice USP.
Are all are all these devices that makes the varnishes and the print and the coatings essentially the same heads and everything?
Yeah.
Or
So
it could have been colors. Just now it's just varnish based,
yeah.
or a primer based.
So the head printing aspect of the print engine it's all the same head technology.
Okay, yeah.
With optimized waveforms depending on whether it's got color in it or not.
Makes sense. And then you have an IR dryer.
Yes. Yeah. So the IR dryer really is to ensure we can pin the primer. So we pin the primer. So when we apply the ink, we get nice flat, not flat in a dull sense, but flat in a homogeneous, even coating when we apply the ink. So we have that pinning capability so that we also then can retain the speed throughput.
Alone, that combination, is that unique to Agfa, or is that also something you see among the competitors?
I think there's definitely other players looking at combination drying. I would say most people either choose hot air or infrared. Because of them, again, I come back to the material range, the speed. What people have seen these 2 days is a press running at 150 meters a minute.
Yeah. Or 492 feet.
Or 492 feet.
Because you can't say 500, right?
Yeah, that's right. Yeah, I can't say 500. So I think we've finally tuned the combination of the hot air and the infrared. And the key of the infrared is that pinning capability.
And now we get to the print heads. As you said during your presentations, currently you have a 4-color version of the machine, but you can basically extend it to up to 7 colors, or
up
6
to
colors,
7.
or?
What you can see here is again the machine build is with options in mind. Options in mind being the potential to add expanded gamut, OVG in the most part. As we're here talking a lot about applications and opportunities for packaging. So with that comes not just food, beverage, is also pharma, healthcare, luxury brand, packaging, but also really we're trying to involve the brands, and it'll be the brands that also help us with this adoption.
Yeah, Rita told me that even sometimes you could imagine that it's not even OGV, it could be other colors that basically are essential for achieving that gamut you need, basically.
Absolutely, yeah. I mean, everybody thinks about expanded gamut as OGV or orange, violet, green. I think I like to link it back also to the primer. So what we really see is this primer CMYK combination. We have a nice USP over achieving Pantone coverage before we need to go into OVG.
So you have a wider gamut than you would
have a
normally
wider
expect.
gamut.
Okay.
Yeah.
And I was just wondering, because I mean it is Fuji Dymatics sample print heads in the machine. So I mean you get a bunch of print heads. I take that everything else around it is pretty much your own, right?
Right. Yeah. Absolutely. You know, we have the combination of the R&D teams from Cambridge, Mortsel in Belgium, working together. The ink development team, the mechanical R&D team, designing and optimizing the waveform. You know, the waveform for the inks.
Is the waveform and the inks, is this like more like the critical part of making something like this work?
Oh, absolutely. You know, I think again most people will see the samples that they've seen. We have. Not only have we actually printed live, but we have shown samples printed off the same press, not reinforced from elsewhere. And that waveform is critical to be able to achieve the drop placement accuracy.
Yeah, because you need to have it precisely, and you have 1200 dpi print head. So I mean, the accuracy of everything that goes on in the machine needs to be like. At that speed, really needs to be controlled.
It needs to be controlled because you can't necessarily see it at such high speed. Yeah.
What about things like redundancy check and things like that? Is that something that it has as well, or?
Yeah. So for each sheet, we have calibration on board. So you'll see as we walk through the QA system. So the camera system is registering.
So it can measure even on a dot basis.
Yeah. So with the coverage of the four-color primer, it's going to be difficult to do that. So we have a space for like a confidence strip. Which is familiar to the analog world, and that then links back to the intrinsic data on the console, where you can see the upper and lower levels of density. And then we can really understand if we have any nozzle health challenges.
When we spoke yesterday, you were very much that it was developed with a lot of like talking to converters, understanding their needs and the market, that. So I guess that when you invest in a machine like this, uptime is, of course, you mentioned it many times, but uptime is essential, right?
Right, yeah. I mean, people don't look at this type of level of equipment to have it just standing on the floor doing nothing.
Hopefully not.
But, I think traditionally, the way we've developed products, we always have a top-level throughput capability. I think what we've demonstrated today is that top-level throughput capability is mainstream. It can be achieved. But linked to that is the expectation. We set a job up, you run it, it repeats, it's reliable. So, in that 7,000-8,000 sheets an hour, reliably, consistently, we get a good level of uptime for a first evolution of such a printer.
I would say that one of the things that surprised me a little bit in your presentation was also that you say that this, because often when you talk about inkjet and new technology, you maybe have a lifespan of 3 to 5 years, right?
Right.
But you say this is industrial scale and basically intended to be minimum 10 years, for example, right?
Yeah, I think, and I link that back to a few things. One, the transportation system, the belt technology. That's not a consumable. It's not a commodity item. Really
so you don't have to replace it. That should basically last its entire lifespan.
I talk about lifetime testing. So in this instance here, we're talking about 10 plus years. So I know going to the converters early doors and seeing some of the presses older than myself, it's quite hard to comprehend sometimes. And they still work, right? And they still work, and that's a little bit the challenge of people with inkjet. It's that, as you said, 3 to 5 year cycle, but we're beyond that.
But I take that also when you look at it, it looks very sturdy, of course, but it still also look like very modular. Yes. So in the same sense, it looked like, okay, if you need to, let's say, in 5 years have a newer generation of things, it could potentially be replaced.
Absolutely, and the modular word is a good word, Morten, because we built modularization into the design intent. So building and shipping these around the world, such a thing is it's going to be interesting. So the modularization aspect is one about shipping and transportation, but also scalability for the future.
Of course, Okay, now we've got the print on paper or on substrate, and now we have 2 more dryers.
Yes. So again, much the same as the intermediate drying between the primer and the inks. Infrared drying for the colors. Again, it's to make sure that homogeneity between the fluids is perfectly matched. And you're not going to get bleed, or maybe if anybody who can resonate with 3 or 4 year old paintings from preschool, that could be how it ends up. So this is critical to that.
So you say you cannot do preschool work?
Yeah, there we go.
Okay, is that look like the same device as there? Is that the same one?
So it's a detection system again. Okay. So of a machine such a expanse in length. Sheets coming through before priming, but after priming and after ink, maybe there's some change in shape.
So that's just to be sure that when it gets to let's say the coding sections, that you have everything from the computer side, so everything is under control. Because again, we now can see you have two coding units there. Digital, again inkjet. Right?
Again digital. I think to link it up, this is also about the sheet reliability feeding. So if a sheet comes through, especially if it's a lighter weight paper, sometimes they'd be a bit curled and a bit cockled. Well, this will detect that, so it doesn't damage anything. It doesn't end up in the stack. So it's part of the protection of the print, the investment, the print heads. But rightly so. We have the varnish bars. So we have 2 varnish bars right now. We have 1 populated with varnish.
Wow.
I guess you didn't know I was going to say that next.
I was a bit surprised to that just when it came out of your mouth now, I must say.
But here we're really going for that soft aqueous finish. So it's all about protection.
But and you said actually also in your presentation that your intention with, at least in this version, was also to say that it's more like not destroying the print or you're extending the print, was more to make that protection surface to get that kind of offset feeling of your finished.
Absolutely. I think some of the other presenters, Rita, for example, when she talked about the technology, Mark, when he was talking about the chemistry over these 2 days, we opted for a binder-free ink. So part of opting for the binder-free ink is to get more out of the ink, but then we need the ability to not damage it post-print. So the varnish helps us do that.
Yeah.
But
is that like cracks and all these kind of things?
Cracking, rubbing, scuffing. The varnish gives us perfect protection.
Yeah.
But the varnish also gives us a compatible link to the next step, folding, gluing, for example.
And when you have them as digital printed, does that mean that you can do spot varnishes if you want to? Or?
Absolutely, yeah. And some examples of spot varnish over these last 2 days. And sometimes maybe there is an application, a material that goes through where actually you don't need the varnish. So the fact that it's inkjet means it gives you full optional control on whether it's required or not.
Fantastic. And then we come to the Q&A system here.
Yeah, so the onboard analytics, the camera system.
Yeah.
So as we've alluded to, this is not a slow printer. It's an industrial scale printer, that can run at 150 meters a minute, nearly 500 feet per minute.
To be more precise, 492, right?
492 there, yeah. I can tell you've been listening these last 2 days.
I have listened to
very good, very good. But yeah, I mean, this is all about uptime. This is all about scaling the production capacity.
Yeah, to be sure that basically, as you say, the most critical things when it comes to the environmental things and also to, let's say, the investment frame is to make sure that you get as many sellable sheets as possible, and it's cheaper to take them out now than take it out in a folding situation.
Yeah, absolutely. Right? So that links to the console, it links to the confidence strip, the correction capability, with all of that in mind. So that what ends up at the end is saleable printable jobs.
Yeah. And then what is this? Is this the
so this is all linked.
One, or?
It's all linked to kind of the temperature control.
Okay. Temperature control.
So making sure that everything is well maintained from an environmental standpoint.
And when you see the isolation on that behind it, it really looks like that it needs to have like again, we spoke about this industrial scale. It looks like it's like dimensioned really well, right?
Yeah. I mean, perfectly tuned to a machine like such a size. Yeah. What's interesting is you have full accessibility through the machine.
So you can go inside.
So you can go inside. Okay. You have a maintenance area, walkway, because part of the size, the footprint is when we're in print mode. We're obviously on job running, but when we're in maintenance mode, we retract the print engine to the home position in the maintenance area. So that allows you to walk through.
Okay, so that basically means when the print heads are back in maintenance, basically there's also, I think you mentioned also something that you will do a lot of, let's say, training to the owners so they can do a lot of maintenance themselves, basically, right?
Yeah, again, I think with something of such a scale and some of the end users we're talking to, these guys are not, they have their own engineering teams, they have their own level of competency, and a lot of them are looking for certified, to be certified to do their own level of support. And I see very much that a lot of where we'll be successful is where we're offering that kind of second, third line. So we need to be able to deliver a level of training.
But it also makes sense from the fact that when you have a machine like this and it needs to run as close to 24/7 as possible, you cannot have it down for even just for a few hours would be critical for some companies, right?
Yeah, absolutely. So and I link that again all back to the print heads, the design intents in terms of you mentioned they were Fuji Samba heads, and it's no surprise that's what they are, but they're not Agfa print heads. So we have to make sure that, again, like the belt, we're not treating those as a consumable. No. So it's all the technology built in, the intelligence built in.
But one of the things you said, and what I also like about it, is you also kind of said that it's like when you build a machine like this, Agfa, maybe you could, but you decided that you don't want to be the best in all the, let's say, little nifty-gritty things. So you focus on doing things. So I think that the collaborative mindset of working with other companies should give it strength. Of course, if the service is on the one hand.
Right. Yeah. Absolutely. And I think that's an important part. Yeah. We will own the service.
Yeah. Because I mean, sometimes you hear converters and printing companies complaining a little bit about that. Okay, the frame is from one vendor, the transport from a second, and the print heads from a third, and so on. And that is also in the size of a machine like this probably a no-go, right?
Yeah, no, absolutely. And I think we started off the discussion around the integration of the third-party equipment, but within integrating the third-party equipment, we have full control.
Yeah, precisely. Yeah.
So by having full control, it means we're the full service provider, right? So
let's move on, and Chica, watch out for the stairs. We decided not to talk too much about the dryer because basically the machine is not running right now.
Yeah, well,
but obviously there's a dryer here.
There's a dryer. One thing I would say, which I think is important,
and that's nuclear powered, right?
yeah, this is industrial scale power, but they are independently controlled. Yeah, it's 3 modules. So the fact that they're independently controlled means we really optimize the power needed. So it's not a full blast of energy. We can control it. So from an environmental sustainability perspective, you really tune that to the infrared. You only use what you need.
And yeah, precisely, because I mean, from the sustainability, you have stressed that several times in the presentations that you try to only use the energy you actually need, right?
Exactly. Yeah. Yeah. As little wasted energy as possible.
Yeah. And then you have again a MABEC on the delivery system.
Yeah. So just before there, this is our kind of reject sample system. Yeah. So I'll link that back again to the kind of mechanical detection we saw, the confidence strip. So if there is a sheet that's detected to be poor state, whatever that may be, it doesn't end up here. Yeah. So this is the kind of dump bin that I've referred to a few times over the last 2 days that can either spit up or down, depending on the material.
I mean, there's one thing you have mentioned more often, and that is 11,000 sheet power, right?
Yes.
Because I think you said that, okay, you actually managed to say it 4 times today in the presentation. Yesterday was only 3 times,
and I was only talking for 4 minutes.
Even more amazing, right?
Yeah.
I mean, but I mean, you get to the point, right?
I try.
Yeah,
I try.
That's great.
Yeah. So same kind of thought process here with the stacker, pallet to pallet, stack to stack. The idea that
right now it's a little bit uneven, but that's just because it's not like set up properly or something like that.
I mean, obviously, we wanted to show the market where we were, but
of course there should be also a place for improvement, right?
Exactly. Yeah. You can't.
Before we talk about the console, I just think maybe we just touch a little bit upon the barrels with the inks, because I mean this is not the tiny little barrels, right?
No, and again I think here there's a couple of reasons. One reason to link it back to is uptime and machine usability, so efficiency. So with a machine such as SpeedSet, you don't want a bag in a box. You don't want a 1 liter or a 5 liter bottle. Change it all the time. You don't want a pot of ink sitting on the side. So this feeds the beast. These are 200 liters, 50, 60 gallons.
I even like, is that new? Because Mike showed yesterday that you have like these mechanism for adding. You don't get greasy hands, basically.
You don't get greasy hands, but also with the intention is we may see the return of the milk float. Yeah. So a lorry turns up, he takes the empty barrels away and replaces it with a new barrel. We reuse it, we recycle it. So it's all part of our circular trend towards sustainability. So it's about maintaining uptime, keeping the beast fed, but also then reuse, recycle, so that we can contribute to our sustainability objectives. And I think I just say that it really is becoming part of everything. The ink delivery system. Here you can see it's just like a little mini ink farm. So
I was also thinking this also indicates that it's industrial scale. I mean, the customers that buy this are customers that print a lot, right?
Right, they print a lot. Yeah. I expect on average 30,000 liters of ink. Somewhere around that order of magnitude.
Per year, or
yeah,
okay.
Yeah.
Wow.
So as a starter, so.
Of course, that should not put the bar too low, of course, right?
Absolutely, absolutely.
And then we have a control desk here and some software. Yeah.
Some software. So I think back to some of the early questions we were asking the converters. It looks, as you say, very industrial, robust, but I think also it has a lot. Aesthetically familiar look about it, like an offset press, but with everything inkjet and digital. The console is a perfect example of that. You have the light box. You have the nice backdrop of the big screen.
So you can still see the football matches.
Exactly.
Yeah.
Yeah, but what you see here now, nicely presented, you've got information on the jobs, the sheets, but you also have the, we talked about the QA system, but we have a webcam inside.
So you can basically see what is going on inside the machine.
Yeah, you can see everything running through at high speed. The light box for inspection, make sure we have the color correction, the density.
And what about, I mean, a machine like this, is it intended to be like a one operator use, or what is it intended for?
I think right now I would say we're 1.5.
1.5, okay.
Yep.
So you suggest that every customer should buy 2?
Yes.
And then have 3 people
There we
employed.
go. Yeah, you got it.
60,000 liters of ink per year, right?
Yeah,
I mean,
it landed.
We take it somewhere, I can see that, yeah.
So, and here we have the operator console, so where all the touch points, the job setup. This is actually linked to another one at the front of the machine, so 25, just under 25 meters long. If somebody's here, but somebody wants to take control
so
there,
you can basically control from both sides.
bi-directional communication.
Okay,
yeah.
Super nice.
And the cool thing here is everything, and it shouldn't be a surprise, I suppose, but everything that ends up printing, it comes with all the information, all the pre-press, the color management, the vacuum setting, etc. And just a nice working environment.
Yeah. So that's super great. Well, again, congratulations on it. I mean, seems that it's not been entirely wasted time, right?
Well, for sure not. No, and I think for me, it's also just the whole team coming together, everything that everybody's been working towards this year. Really realizing that, and it's been a great couple of days, and it's been fantastic that you've been here to experience it, join it, and celebrate with us.
Chica, we had a good time, didn't we? He's nodding, right? Matt, thank you very much.
Thanks, Morten.